right, cool. So we'll briefly introduce ourselves before we dive in. So again, I'm Gil. I currently lead the engineering team at Jumpstart. I previously did a lot of backend, now a lot more management, but previously did a lot of backend, and then before that did iOS development at LinkedIn and Wealthfront.
Yep, and I'm Liam. I previously did a lot of backend and still do a lot of backend at Jumpstart. I'm a senior engineer here. I also help build out our ML and AI resources. Previously, I worked more closely with ML in the voice space at SoundHound.
Yeah, and so to briefly introduce Jumpstart, we are a university recruiting platform, and we use machine learning and AI to pair students with jobs they'll love. We started about 2 years ago, and we're up to almost 150,000 students and continuing to grow every day. So let's dive in here. So yeah, basically what we want to do is talk about a lot of the patterns and things we've encountered as we've grown, pain points we've had to overcome. I think some of these patterns are going to be more obvious. Some of them you'll definitely recognize, and some of them you won't. Some you'll disagree with, some you'll agree with, and that's the beauty of coding. So we're pretty excited to go through this. We would love comments. Liam, if you could, I think Liam's going to monitor the chat and the Q&A. But we'll be responding. We want to hear your opinions. We want to, kind of make this interactive as we go. But we're probably going to, I think we're covering about 5 to 6 patterns that we really love. Again, some of which we learned from others and some of which we kind of came up with as we went. Well, I think I can see the chat here too, so I'm going to get that up. All right, cool. Looks good. All right, so here's some of the topics we're going to go over. I'll let Liam briefly introduce this.
Yeah, so we're going to start today from like the database side. We're going to talk about stuff to kind of help you build the most robust models possible. Talk about model properties, model methods, custom managers that live within your model class, and then custom migrations, adding Python code inside of a migration in case you ever need that. And then we'll kind of move on to like the Django REST side. Jumpstart uses Django REST. Decorating a query set right before serialization to make sure you have all the fields on it. And then testing queries, making sure that your query sets are not performing way more queries than you think, avoiding the n+1 query problem. And then finally, we'll just throw out a couple classes that allow you to make your endpoints as extensible as possible and build the most robust API for your clients.
Cool, thanks, Liam. I see one thing, I think, Arana, you said you want to connect with our team, you teach computer science at a university and would benefit from using the platform. Definitely, please email us, or it's gil@jumpstart.me and liam@jumpstart.me. You're also, feel free to connect with us on LinkedIn. But we definitely have things going on with coronavirus right now. We're offering free access to companies to kind of help students who have lost their internships and jobs, get them. So we're willing to work with companies here. But yeah, we'll keep going here. All right, so to start, this is the mega model pattern. This is something we kind of have adopted over time, and something we recently learned is pretty big at DoorDash as well. I think they're still heavy Django users, though I think they've been migrating off a bit. So basically, one of our goals is to reuse model logic as much as possible, and we have 2 ways. One is via properties, one's via methods. Most people probably have some of these in your code base. So for properties, we want to be able to reuse a lot of our logic, and when we don't have to do a query, but it's something either repetitive or something that is just kind of sloppy, we want to make that much easier. And so, for example, you can see here on Jumpstart, we have users, and we're a 2-sided marketplace, right? So we have students and we have recruiters or employees. So that might be an engineering manager who shows up at a recruiting event. So we have students and employees. They communicate, but they're basically both in a way subclasses of the user model. We have a user table, and then we have employee profile table, which stores things like the company, and then a student profile, which stores things like the school that they go to. So every user has one or the other. When we return the user profile to the front end, we need to serialize that JSON, and the profile is a nested JSON object within the main user object. So you can see here in get profile, for Django REST, this is a serializer method field, but this would be applicable in other places too. Yeah, fighting the legacy multi-profile issue. Yeah, sorry. See that in the chat. Definitely a thing that we continue to battle, and that means we have to do it right and do it cleanly. So you can see there, what we do is rather than everywhere in our code base doing has adder, self, employee profile, it's just ugly. We can use these helpers that make it really nice, easy to read, really easy for new employees to onboard and understand. It also makes it really easy for us to change at any point the definition of what a student is or what a recruiter is or employee, and that applies everywhere across our whole code base. So we are huge fans of this, and we think that anywhere you can do this, you should do it in a very opinionated way. But you should never run a query in here. Can you imagine, someone just, using dot logic and not knowing that you're kicking off database queries? So you want to avoid that. If you do want to use a query or you want to perform more complex logic that might be actually like take a performance hit, we recommend using model methods. So here, for example, this is living on the model. We would have something like get all emails. So our users have a primary email, but then they can also have tons of backup emails, secondary emails they add. We need to do a query to look them up in this case for a one-off. So what we do is we have, you would do the user, like your user object dot get all emails. That performs a lookup in the secondary email address table and then returns all of them as a joined list. This is really, really important that you do not use something like this in a loop, because you're going to hit an n+1 query problem, which is something we'll address, throughout this whole talk. It's a huge problem that we've encountered and something we fought really hard to get over. But yeah, for individual models, this is something you want to use. And now you guys are maybe wondering what happens when you have a query set and you want to do something like this. Like how do we keep this reusable logic clean in query sets? This is something that I'm sure a lot of you are using. Oh yeah, so we were going to explain n+1 a little later, but I'll hop to it right now. I see your question, Manish. So n+1 query problem is something that probably most of you have encountered and may not know by name. It's essentially when, for some sort of serialization of a list, for example, you need to like fetch a list and return it. You have n+1 queries run on the database. Those being, the one query is to get your list. So say we need to return 30 users to the front end. Our one query is saying get all users where X, Y, and Z, and that returns the 30. And then say for each user, we need to return the most recent company they worked at. That's the end queries, because for each user, we're now doing a database lookup to say what was their most recent company? What was their most recent company? You want to avoid that. We all know there are ways to do that we'll get to in a minute. But you will hit that problem if you call something like get all emails in a loop, because you have your users, and then for each one, you're calling secondary email address.objects.filter, which is kicking off a query. Cool.
Yeah, so just how model methods consolidate logic within the model itself. Custom managers do the same thing, but for query sets. I love custom managers. They're an incredibly useful pattern. If you've ever written a bunch of complicated logic inside of a call to .filter and you just dread writing it again, this is what you need. So I'm going to start with an example from our code base just to kind of prove its value. So Jumpstart, as Gil mentioned, is a tool for connecting recruiters to students, but we recently rolled out some social networking products, which allow students to find and connect with other students. So right after we did this, we actually got a ton of feedback from students that they didn't want to be found by other students. They only wanted to connect with recruiters on the platform. So we added this flag that allows students to hide their accounts from other students. But the logic to filter out these students who didn't want to be seen is a little bit confusing. You can see it on the screen here. It involves understanding how negation works in this imported bit field library that we used for the flags, and knowing that the flag exists on this student profile table rather than the user table itself. So rather than expecting every single dev to know this and onboard onto this, we use custom managers. Next slide. Right. So custom managers is a pattern that allows you to override the objects manager class on every Django model with your own manager class. So you can see in the middle picture here, this is how we do it. You just set objects to your query set manager class.asManager. So once you've done that, you can stick all of your complicated filtering logic into a function inside of that manager class, as you can see we did in the bottom picture here. So then fetching those students who don't want to be seen is as easy as calling that function. You can see in the top right picture, it's as easy, it's super readable. Okay, next slide. Cool. So these manager methods are a great way of decomposing and abstracting away complicated query set logic. And then chaining them kind of allows your query sets to read like plain English, assuming you name them well. right? So this promotes readability throughout your code base. It puts all of your filtering logic in one place, right above the model usually, so that in one file, and you know exactly where to look whenever you're doing unit testing or query optimization. It's just incredibly easy to see where all of your query set logic lives.
Yep. And so I think if you ever find yourself repeating filtering logic, that's probably time for a custom manager.
Yeah, exactly.
Cool. And then John asked, is there any reason we return a list here rather than query set? We actually do have another helper that returns a query set. This was a very specific use case in a lot of places that we need this. But yes, we definitely can do that as well. It is just combining fields from separate places, and that's part of the reason there.
Good question. I think we're on the next slide now. Thanks. Okay. So then I want to talk about a pattern that is potentially very useful, but also very dangerous. And so I want to talk about kind of the trade-offs there. So sometimes the state of your database is blocking your deploys. Maybe you're introducing a new model, or you're deprecating some part of your schema, and there's some code tied to it, and you need to run that code at the exact same time. And maybe it's the other way around. Maybe you need to deploy some code in order to run your migrations, and you want it to happen while the migration has the database lock, like when you're introducing a new database constraint, for instance. So that's where the Django migrations run Python class comes into play. This allows you to run Python from within a migration while the database lock is still acquired. Next slide,
Go. One sec here. It's not going. There we go.
Okay, so in the spirit of working from home, everyone's probably heard this meeting should have been an email, or I guess in this case, this Zoom call should have been an email. I like to say this custom migration should have been in a command class. So this to say that the power to put Python in your migration should not be taken lightly. Migrations are generated code, meaning they start out as relatively pristine and bugless, and you're now about to insert your own gross, buggy Python code. So in general, I would actually recommend avoiding this practice of putting Python in your migrations. If your code is not absolutely inextricably tied with your migrations, it probably just belongs in a command class where you can run it from the command line, either before or after the migrations have run. Next slide. But in the case you absolutely must inject Python code into your migrations, I have a couple hygiene suggestions. So I would recommend not putting the Python directly in the migration file, but having a helper method that you import. That way you can put it in a command class and you can run it from the command line in your development environment, try it out, see that it does the right stuff on your database, and then you can even unit test it, maybe with PyTest. And then another thing I would suggest is that the code be multi-runnable, right? So we've had problems in the past of putting Python into migrations that can only be run once. If it were run twice, it would be disastrous. So you want that code to be runnable as many times as possible with the exact same outcome on your database. If something goes wrong, if your migration fails, if it turned out to be the wrong code and you need to adjust it and you don't want to run your migrations again, this allows that extensibility.
Thanks, JJ. Yeah, idempotent. Cool.
Oh, idempotent, nice.
Cool. All right. So now we have another common pattern, and this is that you're often going to fetch something from your database. You're going to have to annotate, select related, prefetch related, do all these things that, again, reduce your chances of having an n+1 query issue. And then lastly, you're going to serialize or pass that object to a template, right? The problem is if you're reusing your models, or say you are using the same serializer across many endpoints, or you have a template that needs your model to have the same fields already pre-selected and fetched, you'll find yourself copying and pasting a lot of this annotation logic, a lot of this, so here we have annotates, but it's the same thing for select related and prefetch related. You'll find yourself copying and pasting that to make sure that those fields are available without kicking off extra queries. And in the case of annotate, it's actually making sure those fields are there to begin with. Because if you fail to annotate a field that your serializer or template expects, then boom, you're going to have an exception thrown. So what we did was we came up with what we call decorate query set. And that is a function that lives on the serializer itself, but is static. So what we do is we we basically will fetch our models like normal. So we have our query set. We then call on our serializer. So let's say user serializer dot decorate query set, static method, and give it the query set. It just returns that exact query set with these annotations. So this is just a place to store the annotations and the select relateds and prefetches that we need for that serializer and return it. And that way, everywhere across the code base, we're not like continually copying and pasting this. And we're able to add new fields to the serializer and have that apply everywhere by just changing the decorate query set in one spot. Same thing for templates. So if you're using not Django REST, you can put this in a template helper. I was trying to think about this before. We personally don't use this, but you could either put this in some sort of template helper file to just annotate for you. And that's just, abstracting away your annotation into a function, which you should probably be doing anyway. Or you could also potentially put it on the model and be like, decorate for certain template type. There's a lot of ways you could do this, but those are just a couple. So another way, and again, we talk about N+1 queries a lot because they've become a big problem for us, or they were a big problem for us for a while. And luckily we've gotten past that. And this is one of the ways we've been able to get past it. By the way, if you have any list endpoints that are slow, this is likely your problem, or a missing index, but that's a different story. So we already talked about what the N+1 query problem is. Again, it's your one query is looking up your list, and your N queries are performing lookups for each item in your list for additional information. How do we catch it in code reviews? So, at first we were just looking for someone who in a serializer was performing a database query. That's clearly going to cause issues because you're serializing lists of objects. But there are less trivial cases, things that aren't easy to spot in a code review. And so what you do is when you're creating a list endpoint, in this example, a user on Jumpstart can answer questionnaire questions, and there's an endpoint to fetch all their answers. So we show recruiters what they said. The problem is we kept having new devs join, and they would add some new information to answers. And every time they did, someone would miss it in a code review, and it would kick off a query for each one. Boom, endpoint slow again. It goes from a constant 13 queries or whatever, and this is including looking up the user, all that stuff, to maybe 60 queries or 80 queries, and then you're getting really, really bad performance. So Django has a certain number of queries, and we struggled with that because as we were writing these tests, the problem was Django is you're actually having cached queries, and you don't have a idempotent number. No, it's not the right uses, but you don't have that constant number because the cache, right? So the number of queries is changing, especially when you're running locally, where you don't necessarily have a clean state every time you're running your tests. So we found an add-on here and we're happy to share this, and also anything else we talk about, we'll share snippets. But we can assert that the number of queries is less than, and we put that as the highest amount it could possibly be. So when it caches queries, that number still passes this test. But if someone were to add something and that number went over the number of queries that we're limiting it to, we're going to get alerted. And the problem is not, you can't have more queries when you're modifying code, but you want to be aware of how many queries you're adding. And this forces you to actually go in there, change the number, and be like, I am aware that I am adding this number of queries to this request. Cool.
Yeah. So finally, we started with models and database operations. We've kind of moved slowly into REST operations and serialization and endpoints. So finally, we're going to talk about how to make your endpoints as extensible as possible. So you can see the client is always right at the top there. So this allows your client as much power as possible to customize the responses coming out of your API. So the first one here is a subclass of a very useful Django pagination class called cursor pagination. The second two ship with Django, and the third is one that we import. By the way, this goes just in general. We are happy to share our code and relevant imported libraries afterwards. Just hit me or Gil up. You can always email us or hit us up in the chat. All right, next slide.
Cool. And do you want to cover query fields Mixin real quick and describe what that is?
There's a slide. There's a slide.
Cool. There we go.
So we're going to start with client-provided pagination. So Django ships with this cursor pagination in the pagination library. When you subclass it and then overwrite the page size query param field as you can see we did in the top snippet there, your endpoint now accepts a query param that allows you to dictate how many items appear in your response. You simply add that new pagination class to your list API view as the pagination class, like in the middle picture there, and you've made that functionality available. Now, your clients can simply add a page size, and they can dictate how many objects appear in the page. And just in general, using Django pagination is amazing because, as you can see in the bottom photo, you get item count and next and previous links for free if you use custom pagination. Yeah, next. Cool. Great. And so the search filter and ordering filter, I'm sure many of you have heard of this before, but we really, really like our list API views at Jumpstart. One of the biggest use cases on our platform is allowing recruiters to sort through a massive list of candidates, of students. And so these two filtering classes have really helped us do that better. So these are found in the REST framework filters library that ships with Django. And so the search filter for any model-based list view, the search filter gives your client this search functionality via the search query param. So on the back end, we simply need to import the class, specify it in the class field here, and then specify the model fields we want that the clients can search over. So in this case, it's like first name, last name, and then their college name, right? And then that gives us, at least on the front end, it gives us that little search bar that you can see in the bottom left. That's what backs that. And then the ordering filter is very similar. The client can provide what you order by. You can do like positive and negative ordering. So you can see in the bottom right there, we have the ability to kind of click on a name column in this like massive table of students, and you can order them forward or backward by name. And then we do it by a ton of other fields, who interacted with the student last, whether they have any notes, etc. It's incredibly useful, and only a couple lines. Yeah. Okay, so finally, my personal favorite, and I'm sure Gil's too, is the query fields Mixin. So I believe the last presentation today is on GraphQL with Django. So we at Jumpstart wish we had GraphQL, but in a resource-strapped environment at a startup, it just wasn't an option at the time that we needed it. So we kind of came up with this solution. And as I said, I didn't want to overload you with code here. So feel free to inquire about this afterwards. But the query fields Mixin is a serializer superclass. So you subclass it in your serializers, and it allows you to specify exactly the fields you want. It allows the client to do that. So yeah, in the top picture, you can see we subclass it there. And in a model serializer, as many of you know, as you can see on the right, in the meta section, you can, in this fields field, you can specify which fields are serialized and sent in the response. So that's how the backend does that. The query fields Mixin is how we let the front end do that. And you can see a sample request URL, or just like a little part of it in the bottom picture there. Simply with the fields query param, they can say they only want a certain number of fields off the model returned in the response. This is incredibly useful for speed purposes, since, as many of you know, serialization can be the slowest part of your API. And so if there are certain fields that are more expensive than others to serialize, this lets your client kind of pick and choose which ones they want and speed up the endpoints without even talking to the backend.
Cool. All right. Thanks everyone for watching. Looks like we have quite a few questions. Please add any more that you have here. And we'll kind of start getting through them here. First of all, John mentioned you can use captured query context to ensure that adding more objects to the universe does not increase the query count. That is a great tip, and we will definitely take that back to our team. I know that for us, this is something we really value, so I appreciate that. And if anyone has other advice about how to manage this and how to onboard new people and make sure they're aware of this problem, please let us know. Cool. We can keep going here. Any recommended resources where an intermediate Django developer can learn more of this stuff? Yeah, that's a tough one. I think truthfully, a lot of the things that we've obtained have been through encountering problems and then looking up solutions to them, or just kind of meeting as a team and being like, how can we solve this problem? So yeah, Liam, can you think of any resources? If not, I'm sure that many people here have plenty of resources they can paste in the chat.
Well, that's certainly true. Someone mentioned 2 Scoops of Django. That's a great Django book. Highly recommend that. And then there's tons of just listicles online. If you look up Django tips and tricks, like the first couple of Google results are amazing.
Totally. Another thing I recommend is actually just taking, a few hours at some point and reading through the docs in Django. What you do is like, you don't necessarily memorize everything you see, but you become aware of certain concepts. And then when you're trying to solve a problem later, you'll be like, wait, I know I read something about that in the docs. Go back to it. Boom, it's perfect.
Yeah. Also, reading the source code of the classes that ship with Django is incredibly useful. They're really, really well documented. Like the way we knew how to use cursor pagination was literally just reading like the comments at the top of the cursor pagination class in the Django libraries. So highly recommend just poking around in Django code if you ever want to learn how to use it well.
Yep, totally. Also, yeah, I love this. Read the docs and dive in. I think like we switched to PyCharm, which has been really nice because I think you can get good plugins for VS Code that'll let you do this, but we can follow code paths and dive deep into the actual like Django framework and understand how things are implemented, which has been huge for us. For example, list API view only lets you return a single type of model. We needed a mixed list, and we were able to do that by overriding functions that aren't really fully meant to be overridden, but made things possible. So recommend that. Okay, Sergey, how do you manage database index structure for maintaining complex queries? Yeah, so that's an interesting one. So I believe this is a default setting. Django will Django will automatically create indexes for foreign keys in your models, which has been super useful, but there are definitely times that they're missed. We've skirted indexes, for example, by doing like case sensitive comparisons. And that caused, like, for example, our forum, I think we made one line change. Boom, our load time went from 200 milliseconds to about 40 seconds. So we had to do a quick revert there. But overall, I think you kind of have them created for free. And if you need one, you kind of know it. And you just, index equals true, or potentially add a more complex index, which we have a few of those as well. Liam, you want to take the next one here?
So for multi-step queries that involve, I guess I'm reading from the bottom, sorry, but for multi-step queries that involve lookups to other tables, is it better to separate model managers at the, I'm assuming, table level, or is there a best practice for multi-table model managers? Yeah, that's a really interesting question. And generally, as Gil said before, you don't want to be doing anything that you wouldn't, that just reading the name of the function you wouldn't expect to happen, right? And so, there's a couple different approaches to this. We actually are pretty bad about it. We just hit other tables if need be, try to keep that to a minimum. You can also just have a generic model manager that sits at the highest level of the query set manager class that you can use to address a bunch of different table queries. But generally, we've just found it works to go cross-table within a single model manager. Just whichever table is being touched the most is generally the rule we use.
Yeah, an example there would be like, say we want some custom manager method, like has worked at company. Say our front end, they want to be able to filter for students who have interned at Google. So we would have something like in our manager called has worked at company, and then pass it an organization ID. That model method would perform a join to the other table, to the experiences table, to find people who have worked there. And warning, like being totally honest, we have some queries that have grown to probably 250 lines, and it's been a real effort to reduce that. So you do definitely want to be careful there, be aware of that, and monitor performance. And also just think about that when you're structuring when you're structuring your tables and everything. We ultimately resorted to building what we're calling our summary table, which is a kind of like denormalized table that has about 60 to 80 columns. That's just all the information across all these tables, and we're updating it regularly. Not a great thing to have to resort to, but it is something that tons of companies are doing I know Uber is notorious for having summary tables. So
yeah, and one last note on that: if you absolutely must do cross query methods within Model Manager, I would recommend every time you need to touch that other table, use the Model Manager, right? So if you need to touch as Gil said, the experience table from within the user Model Manager, use like an experience model manager method, and that kind of keeps everything in its place, organized, readable.
Cool. So Manish asked, since we're using the fields mixin, what is the advantage of using GraphQL? To be honest, the query fields mixin is nice, but it doesn't come close to GraphQL. First of all, you only get top level field selection. So if we want to say we have like our top level user, and then that user has a student profile that has 10 fields under it, we can't choose which fields of the student profile to include. It's all or nothing. You could use a mixin that supports that multi-level, sort of thing, but we figure at some point you're building so much that you're approaching GraphQL, you might as well use GraphQL. There are other issues too, like you don't want to do all these joins if you are only returning certain fields. So there's a lot of logic to be added there.
Hey guys, I'm going to step in. This is a great talk. We want to give some other speakers some time to talk. I do have one question that's a little more high level. There's a lot of reasons to modify Django and to adopt some of the patterns that you talked about. Some of them are around the growth of your team and adding more engineers. Some of them are around performance. You may be serving more customers and scaling as a company. I'm curious which of those two kind of have driven the evolution of your Django code base?
To be completely honest, like growth has been important, but I think we believe everyone can learn and get there. Performance has actually been a huge reason for us. We've had serious performance issues with Django, and N+1 queries, we've mentioned it so many times, was a huge driving factor for a lot of these. So yeah, I would say it was performance first and onboarding people second. But they do run hand in hand, right? You have new people, they have performance issues. So.
Got it. Very cool. Thank you so much, Gil and Liam. This is a fantastic talk. Really appreciative of you guys joining.
Thank you, everyone. Again, feel free to ping us, LinkedIn, email, gil@jumpstart.me, liam@jumpstart.me.
Anytime.
Yeah, have a great night.
Thanks, guys.